Okay, so let's move on to problem 3. Which has a greater resistance, 75 watt bulb or a 100 watt bulb? Suppose you connect a 75 watt bulb across only 50 volts. Will you still get 75 watts of power? Suppose you connect a 100 watt bulb and a 75 watt bulb in series and then connect the combination to a regular 110 volt line. Which bulb, if either, will burn brighter? Note we are talking about the older incandescent bulbs here. The newer types are quite different. Okay, so just before we get into anything, I'm just going to kind of discuss how incandescent bulbs work. So the way these guys work, right, they're the ones you see in all the cartoons and whatnot when somebody has an idea. Of course, you've seen these. And so what they do is they have this filament where the part of the filament, specifically this one, has some pretty decently large resistance. So what happens is it dissipates power and it heats up and it lights up. And that's actually where the light comes from. Okay? So when we're talking about a 75 watt or a 100 watt light bulb, that's the power that's being dissipated in that filament when you plug it in and turn it on. So the question here is, the first question at the very least, which has greater resistance, a 75 watt bulb or a 100 watt bulb? So we're going to take our voltage to be that of just a normal outlet, so a 100 volt line, which means the equation we want to use is a combination of P is equal to IV, the power equation, and the voltage equation, V is equal to IR. Okay. So we don't necessarily know what our current is, but we can solve for current using this equation to get I is equal to V over R. And then plugging in for I in our power equation, we get the relationship the power P is equal to the voltage V squared over the resistance R. So we can actually solve for the resistance given our 75 watt bulb and our 100 watt bulb. And even so, to actually answer the question that's asked, we don't necessarily have to solve for any numerical values. We can just look at the relationship between P and R, because we know the voltage between our two bulbs should be the same, which means the greater the power, the smaller the resistance. And in that case, a 100 watt bulb will have smaller power and thus greater power and thus smaller resistance. Whereas for a 75 watt bulb, because it has less power, it's going to have more resistance. I am actually going to go ahead and just solve for the resistances so we can actually see that in action. So to do that, I'm going to multiply the R over to the other side, divide P over to the other side, and we're left with the resistance. R is equal to the voltage squared over our power. So for the 75 watt light bulb, we're going to use that 110 volt output squared divided by our 75 watts. And this will give us a value of 161.33 ohms. Doing the same thing, but instead for our 100 watt light bulb, we will get 110 watts squared over our 100 watts. Oops, I made a mistake. That should be 100 volts, not 100 watts. Or 110 volts squared over 100 watts. In doing all this, we've arrived at a final resistance for the 100 watt light bulb of 121 ohms. And so just as we expected, the higher wattage light bulb is going to have the lower resistance. Okay. So specifically, I'm actually going to keep the 75 watt resistance up here for use later in the problem. And we can move right along. Okay, so part 2 of this problem says, suppose you connect a 75 watt bulb across only 50 volts. Will you still get 75 watts of power? So the thing we have to look at here is, what are we changing, right? We're changing the voltage that we're dealing with. So looking at the equation, P is equal to V squared over R. We're changing the voltage. We are not changing the resistance, right? Because as I mentioned, the resistance is due to the filament, which is an inherent property of the incandescent light bulb we're working with. So we're still working with that 75-watt light bulb, so the resistance we have is still the same. But what's actually going to change is the power output, right? And so what we want to do is we could actually plug in here. Instead of plugging in 110 for our voltage, we're going to plug in 50 volts. Square that. Divide by the resistance we solved for in the previous part, so 161.33 ohms. And after doing this, we get a value for the power of 15.50 watts. And so right now you might be asking, if it's called a 75-watt bulb, why doesn't it always output 75 watts? And the reason for that is because they're called 75 and 100-watt light bulbs because they are made to work with a very specific voltage, specifically the 110-volt line that we have with outlets, right? Outlets are uniform. They're always 110, unless you have some sort of transformer that actually changed the voltage you're dealing with. So if you do change the voltage, you're going to get a different power. Okay, so part 3 says, suppose you connect a 100-watt bulb and a 75-watt bulb in series, and then connect the combination to a regular 110-volt line. Which bulb, if either, will burn brighter? Okay. So for this, we're going to have our 110-volt line. And connected in it, we have our 2 resistors, which are just our light bulbs. Where we have our 75-watt light bulb. Or 75-watt light bulb, not ohm light bulb. And we have our 100-watt light bulb. So we want to know which one of these is going to burn brighter. So the first thing we know is because these are in series, the current through these two are going to be the same, right? Because there's no branch for the current to split off into, which means whatever goes through the 75-watt light bulb, that same current has to go through the 100-watt light bulb, which means the equation that we're curious about here, instead of being V squared over R, it's now going to be I squared R. Right? And the way we get that is similar to how we got V squared over R, where we take the equation P is equal to IV, and we also take the equation V is equal to IR. By plugging V is equal to IR into this equation, we get the equation the power is equal to I squared R. Or in this case, we see that the power is equal to the current squared times the resistance. And because both of these light bulbs have the same current going through them, but have different voltage drops across them, we can use this equation to better understand what's going on. If we did know the voltage drop across each of these light bulbs, we could use the original equation. But we don't necessarily know what that is, so instead we want to use this other equation. And in this case, we see that the resistor with the higher resistance is also going to have the higher power. And because we know that R75 had a greater, the 75-watt bulb had a greater resistance than the 100-watt bulb, that means we also know that the 75-watt is going to have a greater power than the 100-watt. Which means, because it's dissipating more power, it's going to burn brighter. And that answers the question. Okay, so that does it for problem 3.